Hello everyone. In this video, we will continue with the endowment insurance, covering an example involving covariance. Consider again an end-year endowment insurance of 1 on a person at age X. Let Z be the present value random variable for this insurance. We have this PMF. Recall that we can express the endowment insurance as the sum of an end-year term insurance and an end-year pure endowment. We have the expected value of Z equals the expected value of Z1 plus expected value of Z2. And in the last video, we evaluate the variance of Z with this expression. And now we directly work with Z1 and Z2 to get the variance of an endowment insurance. Variance of Z equals the variance of Z1 plus Z2. Expand this, we get the variance of Z1 plus the variance of Z2 plus the covariance term, 2 times the covariance of Z1 and Z2, the covariance of an end-year term insurance and the end-year pure endowment. The covariance term, by definition, this is the expected value of Z1 times Z2 minus the product of the expected value of Z1 and the expected value of Z2. The expected value of Z1 times Z2, inspecting from the PMF, this is 0. And therefore, the covariance of Z1 and Z2 equals the negative of the expected value of Z1 times the expected value of Z2. In terms of the big A notation, the variance of Z can be expressed as we have variance of Z1 and then variance of Z2 and the last term, the covariance term. That is, if we know the value for the expected value and the variance of the end-year term insurance and the end-year pure endowment, then we can get the variance of the endowment insurance using this relationship. All right, so let's take a look at an example. Given that Z1 is the present value random variable for an end-year term insurance of 100, the death benefit is paid at the end of the year of death. And the second policy, Z2, the present value random variable, and this is an end-year endowment insurance of 100. Again, death benefit payable at the end of the year of death. We are also given 4 quantities, the expected value of Z1, the variance of Z2, and then the 2 big A notation corresponds to the end-year pure endowment. The expected value for that is 0.3679, and then the second moment, 0.1653. We need to get the variance of Z1, the variance of the end-year term insurance of $100. Let's take a look at the solution. In terms of the big A notation, the end-year term insurance of 100, we have this notation. And then for the end-year endowment insurance of 100, the second policy, we have the big A notation here. And then let Z3 be the pure endowment of 100 issued to HX. And the corresponding big A notation is this one. We can relate these 3 policies by this expression. All right, so we have Z2, the endowment insurance equals Z1 plus Z3. Z1, the end-year term insurance, and Z3 is the end-year pure endowment. to get the variance of Z2, which is equals to the variance of Z1 plus Z3. We get the variance of Z1. This is the quantity we need to get. And then plus the variance of Z3 plus the covariance term, 2 times the covariance of Z1 and Z3. The covariance of Z1 and Z3, we get the first term on the right-hand side, the expected value of Z1 and Z3. Recall the PMF between the n-year term insurance and the pure endowment. Z1 times Z3 is 0, which gives the remaining term minus the expected value of Z1 times the expected value of Z3. We need to get the variance of Z1. We have the variance of Z2, which is 137.07. And then we need to get the variance of Z3 and the expected value of Z3. We already get the expected value of Z1. This is given. The expected value of Z3 in terms of the big A notation, we can get the quantity because we are given that the big A notation here is 0.3679 times 100. And then the variance in terms of the big A notation, again, we get this quantity. The variance of Z3 is 299.5. All right, from this expression, we can get the variance of Z1. And the answer is 767.6212. All right, that's it for today's video. Thank you for watching and see you in the next video. In the next video, we will cover deferred insurance.